Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 35 years, and today our topic is the nervous system. And this is the logo I created. When you click on this green circle, you can see all my 78 theories. And this says Science by Vahan Davudyan, How to Promote the Science, Unique Physics Concepts. And this is my email, vahandavudyan1948@gmail.com. And in fact, this is going to be so comprehensive because I had to add 3 new concepts to this theory. And I also used the Smithsonian Science Book, which is one of the most important scientific institutions in the world. And I hope you will love it. And then as we go through, I will explain everything. And in fact, this is the single neuron, and see, I had to enlarge this so you can see everything. But the entire concept is, well, of course, it started in 17th century, that, when we feel something, heat, cold, pain, or some other things, everything is electricity, or it's a moving of charges. And then what it does, this is the single neuron, charges are going through this so you can feel it. Well, of course, I have to go step by step. I will explain it for you guys. And one amazing thing about the human body, or the animals, is that we have 2 important elements in our body, which is sodium and potassium. But why don't we have like magnesium and calcium? And I will explain later. And imagine, both of these are so important in our life because they carry electricity, or in other words, our nervous system works with sodium and potassium. I will explain that. And one important thing about this, sometimes in order to understand the laws of physics, you have to go to chemistry. And you can see sodium has extra electron on the outer shell or the last shell, and so is the potassium. And it's so easy for them to lose that electron, and they can conduct electricity, or in other words, they become ion. So this is important. And imagine everything in our body. Well, I will show you later. We have sensors, and this is the way it carried by electricity. And then step by step I will explain everything, how they work. So let me get another poster. In fact, so many scientists work on this. This is called the nervous system. How do we get these impulses, or electricity in our body? And in fact, this started in 17th century and then all the way to 18th century, which I will explain it later. And his name was Luigi Galvani, and it was accident, so electricity was born. So in other words, after that we had Alessandro Volta came over and invented the battery. In 17th century, that was his name. His name was Jan Sumardem. I don't know how to pronounce that. He removed the frog leg with a, nervous thing attached. Then he tried to pinch that nerve, and what happened? He saw that the, legs frog was twist. And that was amazing idea because people were thinking how you could sense things. And then after that, in late 18th century, this was so important. Luigi Galvani was dissecting a frog, and what happened, that wasn't even him, that was his student. And then they realized when they touched the scalpel, which is at that time was iron, I think it wasn't something else. When they touched the nervous system of that frog, dissected frog, and then the dead frog twitched the leg, and then they had no idea what that happened. Well, in fact, they had a scalpel which was iron, and then also the holder was like brass or copper, which is 2 different metals. And in fact, he theorized, Luigi Galvani, this is called animal electricity. Well, he was absolutely wrong because he had no idea what the animal electricity was. So Alessandro Volta was also Italian. He was, his, friend. Then he heard about that. So he came over and checked the experiment. He said, no, Luigi Galvani, you're wrong. That is not, that is not animal electricity. That has to do with the two different metals. But anyway, they become enemy and then they fought. And then they did not accept their ideas. They could not compromise. But anyway, Alessandro Volta was right. It was not because of animal electricity. It was because of two different metals. But he published a book and then he went on lectures, so many lectures. But finally, Alessandro Volta proved that point that whatever the Luigi Galvani is talking about, the animal electricity is absolutely wrong. So he proved that. Well, he was physicist. That was the thing. He said, my idea or my theory is that electricity or flow of charges because of having two different metals. And in fact, one of them, the scalpel, was the iron and the other one holder was copper or, brass. That's why it conducted electricity. But they had no idea that, what is causing that flow of, charges or flow of hydrogen ions. They had no idea. The human has a plasma, or even our blood, or anything in water, or even tap water, they have hydrogen. So if you put two like a copper and the brass, then you measure it with a voltmeter or multimeter, it shows less than 1 volt DC, which shows that, those hydrogen ions are transferring electricity. Well, unfortunately, because of public perception, most people think that the electricity is carried by the electrons. It is one way, and the other important one is the ions. Think about the battery. We have a 12-volt battery. Outside is electrons, flow of electrons. You get 12 volts, 6 volts, or whatever. But inside is the chemicals. And imagine the chemical factory making the electron flow. But what happened? Inside the battery, we have like hydrogen ions and we have sulfate ions. So what they do, they also do electrons. Well, of course, by the end of this theory, I have some experiment. In order to substantiate my theory, I had to do some experiment with potato, tomato, so many things, banana, tap water, even sulfuric acid. And then no matter what, if you have two electrodes, it doesn't matter. It can be aluminum, can be copper, can be magnet, anything. You put two different metals, they conduct electricity. Well, of course, Alessandro Volta was an amazing scientist. And then he remembered once he had two coins. I'm not sure it was gold or silver. So he put it in his tongue, under the tongue, and then human body has a little bit sulfuric acid. I'm not sure how many percent, but it's a very low percentage. And hydrochloric acid, they have a lot of hydrogen ions, so they can conduct electricity. So he realized he put those two coins in his mouth, then he could have that sensation, tingling sensation, which was, I would say, millivolts. But imagine even the millivolt, the human tongue is so sensitive, can, have the taste and everything else, even the voltage. If I have two metals and then I disinfect them, clean them so good, put it in my mouth, and then get a voltmeter, it shows like 1 volt DC. But of course, that is not going to turn on any light bulb because the current is so low. But because my mouth is a saliva and that hydrogen atoms, so they can do that. Well, of course, Alessandro Volta has no idea about the electronegativity, why two different metals do that, but his conclusion, his theory was absolutely right, and then he realized because of the, two different metals, that's what happened. Then the frog leg, when they had that exposed, that, blood or whatever, the plasma, that was conducting hydrogen ions. So after like 100 years, another genius came over. He was an American chemist. His name was Linus Pauling. And he got 2 Nobel Prizes, one for the politics and the other one was the chemistry. He was great scientist. And then he was the one who devised this electronegativity. I give you some example. Copper electronegativity is 1.9 and then zinc is 1.6. So electronegativity means, how strongly the electrons are transferred from one metal to the other. And it's always from copper because it's 1.6 to zinc, which is zinc is 1.6. So that transfer electron causes, electricity. Anyway, so I did this experiment and then I can prove it for you guys. And by the end of century, this was a Spanish microscopist. His name was Santiago Ramon. He proposed that the entire concept of these neurons, they don't fuse together, but because of exchanging ions, they transfer the impulses. So in other words, when I sense something, those impulses are carried over in those, cells. So that's why I can feel it. Let me see what else. So when we detect something, that is so important. Imagine temperature changes converting this physical stimulus. So sometimes, human body, we have we can call this, room temperature. 72 or whatever. When it's too hot, or, when we touch something, oven or something everything is, stimulated. And after that, what happened? We can sense things. My logical, analysis that, electric charge is carried not only by electrons, but also by ions. Like I said, sulfuric ions and that. If I have pure water and then I put 2 electrodes, it's going to show 0.8 volts or less than 1 volt. But if I put a little bit, acid, sulfuric acid is going to show more. The reason why sulfuric acid has more hydrogen ions than sulfur ions, and then what happened, get almost 1.2 volts. I have another poster, let me put that on. This poster is extremely important because this was done with four scientists, and then they realized that, this is called the potassium sodium channels. And if you remember a few minutes ago, I talked about that Spanish person, and this is so amazing. Our creator God, how did he know? He was the best physicist practically. How did he know we have to have in our body sodium and potassium? Those two are so reactive, so they can conduct electricity. And you can see here, sodium is coming out, sodium ions, and the potassium coming in. That creates a current. It doesn't have to be electrons. Even the ions can clear it, it can create the current. That's why we can see. And this is one nerve you can see. I had to compare this. You can see all those bundles. They are thousands, millions of neurons. And see that bundle? I had to compare this with this, optical fibers. Well, of course, this is much more important than optical fibers. You can see in one little thing, maybe like 100 neurons here. So everything is carried by the neurons. And this one shows the entire human body. You can see from the head all the way to the toe, they're all nervous system. That is the way we can feel everything. Now I am going to show you my experiment. What do I mean by, that, like I said, I had to substantiate my theories with this experiment. Let me put this up so you can see my experiment. This is a brass and iron, exactly the way Luigi Galvani did. But let me put this up, you can see. See, this is a tap water, but overall tap water is not a good conductor. But what it is, it has hydrogen ions. If I put a little bit more acid, it might even show 1.5 volts. But because there is no acid in this, let me show you here. I can show you both with this meter. This is an old one called analog. See, copper is the positive and zinc is the negative. Did you see that, what happened? Did you see that? So if I reverse this polarity, exactly like a battery, this needle is going to go backward. You see here? Did you see what happened? I can also do this with the new ones, which is, this is Fluke, which is the one of the best meters in the world. Let me show you here. This is more accurate. This Fluke is one of the best in the world. So let me show you here. So positive and negative, see, it's showing 0.8 volts. But if I reverse the current, see what happened. This is going to show minus. Did you see that? It's showing minus. But I have to explain here one important factor, which he was one of the greatest minds in the history of science. His name was Henrik Lorentz. And he was in Solvay conference for so many times, and he was the big boss. And then he got a Nobel Prize with his student, Peter Zeeman, and he was great scientist. And this is a Lorentz forces. So I have to simplify this for you. The entire concept is, moving of charges in a magnetic field. So there's a magnet over here, but of course you don't see it, and there's a coil over here. So the more current goes in, it's more deflection. The less current goes in, it's less deflection. That is the basic before this, digital was. So these are Lorentz forces, and like I said, they will be activated with the millivolts. See, if I put this, see, it's going to go backward. But if I put this on a plus, it's going to go forward. Okay. Now, we can use like potato, we can use banana, we can use anything, So the reason why potato, see, let me show you here. Potato has hydrogen ions, see? Did you see that? But if I reverse this, the Lorentz forces are going to be exactly the opposite. So my best analogy is I'm checking a battery, so I reverse the current. I have also banana here. It's the same thing. I can have lemon, anything. I just wanted to show you the, that experiment, Mr. Volta did. Well, of course, I had to put more coins here. So as you can see here, I have silver and copper. Well, of course, not 100% silver. So let me show you here. So penny is the positive and the quarter is the negative. So let me show you here. Well, of course, this is not going to show exactly 1 volt DC because, you know, the surface is not too big and, you know, we get less electrons. Yeah, showing 0.5 volts. So anyway, the whole concept is flow of, ions. There are some other things I have to mention. This was great German scientist, and in fact, like 150 years ago, there were telegraph. And unfortunately, the problem was if the telegraph was like 80 kilometers, 100 kilometers, they had to have 2 wires. So one wire was, you know, going, and then one wire was coming back. This scientist, German scientist, was genius. You know, his name was Steinhaller. And then what happened? He said, you know, instead of using the second wire, I can use the railroad. Well, his idea was almost right, but it didn't work out. So what he did, he said we can use the earth. If I have a pot, then, you know, a little bit soil on it, and then I put these 2 electrodes, it's going to show 1 volt. And like I said, the ampere is going to be so low, but it's not going to light up any, but you know, it can have millivolts. So what this scientist did, like almost 100 kilometers, they used earth. But the point was, most of the time you need to put where the electrodes are, you have to put a little bit more water so they can conduct more electricity. Let's see, what else do I have here? Telegraph, earth, and then I think I have covered almost everything, and I hope you guys love it. And then, you know, I tried to put these things all together, and especially I added my ideas for the sodium and potassium, why we have sodium and potassium in human's body, animal's body, and then you know, I show you the experiment. So I'm hoping that you guys love this experiment, and if you love them, you can go ahead and subscribe, and anytime you have any concern or anything, you can email me, and then I'll be happy to, you know, always to answer. Even if I don't know, I will research, because I'm a best researcher. I can research everything for you guys, because, you know, I can dig it out for you. Thanks a lot for watching, and I hope you love it. Thank you. Bye bye.